So the last lesson of this unit really should be a review. It's solving rational equations that turn out to be either linear equations or quadratic, either one solution or two, either no factoring or factoring. All right, so when you solve rational equations, if the equation is already set up as a proportion, then you're just going to cross multiply and solve whatever is left over. If the equation is not set up as a proportion, then do math. Way back in September, do math. Clear your denominators and solve whatever's left over. Make sure you check your solutions because sometimes you might get a value that won't make sense or that would give you an error message on your calculator. For example, if you realize that when you're solving anything that has a fraction in it and you cannot divide by the number 0, if I were to look at number 1, right, in my denominators, well, I should hopefully realize that this denominator, if that x value comes out to be a -5, it's going to make that fraction over 0. It's not going to work. If I take a look at this denominator, a +3 is going to make that denominator 0, and that answer is not going to work. So when I solve, I'm going to go back and check to see that none of my solutions are -5 or +3. Okay, well, here's my proportion. All I need to do is cross multiply. And when I cross multiply, I'm going to multiply that diagonal times that diagonal. So what ends up happening is my yellow diagonal becomes 2x times the quantity x minus 3. My green diagonal becomes x times the quantity x plus 5. Well, get rid of your parentheses. 2x squared minus 6x is equal to x squared plus 5x. I've got a quadratic, I've got the x squared, which means I need to set the equation equal to 0. I'm going to bring this x squared to the left, and at the same time, make sure you can follow this, I'm going to bring this 5x to the left-hand side also. By doing all of that, my right-hand side, x squared minus x squared and 5x minus 5x, there's my 0. When I combine like terms on the left, 2x squared minus 1x squared is x squared. -6x minus 5x is -11x. Here's a quadratic. This is factorable. I can factor by GCF. X times the quantity of x minus 11 equal to 0. I'm going to drop my wall. I'm going to set my two factors equal to 0, which means the left-hand side is x equal to 0. My right-hand side is x minus 11 equal to 0. I'm going to solve the right-hand side because the left-hand side is already solved, and then my answer becomes x equals 11. So I've got two solutions, x equals 0 and x equals 11. Either one of those will work in either denominator because remember, I couldn't have a -5 and I couldn't have a +3. The fact that I don't have either, my answer to this particular proportion are those two choices. Okay? Let's take a look at the other one. This one is not in a proportion. This one is just a regular equation. Well, their denominator, if I want to clear them all, would be 3x squared, or I should say my common denominator, right? So the common denominator should be 3x squared. What I'm going to do is I'm going to multiply everything by 3x squared. I'm going to do math. Well, 3x squared divided by 3x squared is 1, and 1 times x minus 4 is x minus 4, plus 3x squared divided by 3x squared is 1, and 1 times 2 is 2. 3x squared divided by x squared is 3, and 3 times 3 is 9. On the left-hand side, combine like terms, x minus 2 equals 9. Add 2 to both sides. By the way, this was linear, not quadratic. X equals 11. If I look at my denominators, the only way that any of these denominators are going to turn into 0 is if x is 0. Well, x isn't. X is 11. That's your answer. Number 3, it's a proportion. You're going to cross multiply. Well, x times x minus 2 equals 5 times 3, or 15, which means x squared minus 2x equals 15. It's a quadratic equation. Set the equation equal to 0 by subtracting 15 on both sides. I'm going to solve this by I am x minus 5, x plus 3 equal to 0. I'm going to set my 2 factors equal to 0, and I'm going to solve. This comes out to be -3. This comes out to be 5. As it turns out, both of those values are going to work, because if I look at my denominator, the only value this can't be is a 2, and none of those answers are 2's. Let me just show you something real quick on the calculator so you can kind of see why this is making sense. I'm going to type in this proportion into my calculator. I'm going to type the left-hand side of the equation into y1 and the right-hand side of the equation into y2. And I'm going to look to see where my y values, for which x values, my y values are the same, if that makes sense. So let me just do second plus sign 7, enter 2. Okay, I'm going to go to y equals. The left-hand side of that problem was 5 divided by, parenthesis, binomial, x minus 2. Okay, that was the left-hand side. The right-hand side was x divided by 3. What I'm going to do is go to my table of values, and I'm going to start looking for where are the y values the same. So here's one place where the y values are the same. When x is 5, both y values have the same answer. The other answer that we're supposed to have gotten was -3. By the way, see how there's an error message there? We said you couldn't divide by 2. Let's go up to -3. I believe that was the other answer. And there you see it. If I were to plug -3 in for the x's, both sides of the equation would be the same. All right, so you're looking for which value of x is going to make both left and right hand side equal to one another. 4, not a proportion, just a regular equation. Common denominator, or least common denominator preferably, is 4x squared. We're going to do some math. 4x squared divided by x squared is 1, and 1 times 3x plus 15 equals 3x plus 15. 4x squared divided by x squared is 4. 4 times 1 is 1. Is 4, sorry. Minus 4x squared divided by 4x squared is 1, and 1 times x minus 3 is x minus 3. But be careful here, right? That's a binomial up top, which essentially means you're going to have to think about distributing in a -1 into that whole parentheses. So it becomes 3x plus 15 equals 4 minus 1x plus 3. Make sure you're good there. What happens now, 3x plus 15 combined like terms equals 7 minus 1x. I'm going to add 1x to both sides, and I get 4x plus 15 equals 7. I'm going to minus 15. I'm going to minus 15. I'm going to come over here and say 4x equals -8. Divide 4, divide 4. X is -2. Is -2 allowed to be a solution? And sure, because my denominators just can't be 0, and that's not what my answer was. All right, proportion, cross multiply. 2 times x minus 1 is -5 times x plus 3. Distribute 2x minus 2 equals -5x minus 15. Add 5x. 7x minus 2, -15. Add 2, 7x, -13, divide by 7. And you don't get an integer answer, it doesn't matter. Okay, so what's going to end up happening here is your answer is going to be x equals -13/7. Okay, it doesn't have to be an integer answer, not a big deal. Don't let that bother you. Alrighty, I think this is the last one, right? So cross multiply. Now I've got this binomial times this binomial. And I cross multiply the other diagonal, and it's this binomial times that binomial. Now when I FOIL, right, x squared plus 5x minus 3x minus 15, which is x squared plus 2x minus 15 equals x squared plus 1x minus 6x minus 6, which comes out to x squared minus 5x minus 6. So now I've got to set this equation equal to 0. Why don't we bring all the x squareds to the left-hand side? I'm going to bring everything to the left-hand side, really. Well, let's go for the x squareds first, because you have to notice what's going to happen. If I try to subtract x squared from both sides, they just completely cancel out. So I don't really have a quadratic. I'm left with a linear equation, which is 2x minus 15 negative 5x minus 6. I'm going to add 5x to both sides. 7x minus 15 equals negative 6. I'm going to add 15 to both sides, and I'm going to get 7x equals 9. And now I'm going to divide by both sides of 7, and here's another answer where you don't get a nice integer, you get an ugly fraction. Who cares? A fraction is still an answer. It's still a real number. So this one we thought was going to end up being a quadratic really wasn't. It was just a linear equation. All right, so this really should be a huge review from the beginning of the year. Should be no reason to not be able to cross multiply and solve, and factor and solve if you need to, or just solve a regular linear equation. All right, so good luck on your homework.